Hello. Good day, everyone. Good day or good evening to you guys. And alright, so I'm a little excited about today or what's happening today. Because for this episode, we're gonna talk about my little project. Okay, this is a very unexpected. I mean, it's expected because I've been putting the link under the YouTube video, under my YouTube video. Basically, this I'm gonna zoom in this in. Basically, this little project of mine or uh, Google form is Solve It. So basically, I call this Solve It because this is a way for you guys to like interact or probably send me some problems that you're having problem with, or some send me some questions that you guys are like want to like ask me or want some help. Okay, and I haven't been like checking this because last time I checked, which is like probably last week, there's zero response. Okay, so basically I just started, right? Anyways, so solve it is I'm gonna post the link on the description. I'm gonna post the link also on the comment section. Okay, so you guys better check out if you guys want. You guys can send something. Basically, this Google form, I'm gonna explain this. I'm gonna solve problems for you guys. Okay, so please refrain from pranking and trolling. Okay, so of course, I want to help students. I want to help you guys with your problems or with your academics, right? I pranking and trolling, although I would be willing to entertain them, but it's not gonna help anyone, and it's not beneficial for me and you, right? Anyways, this is to help students, people with their questions, and then be able to gain knowledge and gain insight. I hope so, right? I hope so. I hope so, right? Basically, this is only for in good eh, it's only this is only for the good of for the students or for good of everyone, right? And also you guys could interact and send me your problems. Sending a problem, not necessarily I will be able to do it right away. Sometimes life is hard. Yeah, uh I haven't checked my email or my this Google form for like probably 3 days or 4 days. So I'm guessing at most these guys are like waiting for my answers or waiting for a reply for a while, right? So I'm sorry, but yeah, so I didn't expect this. I'm happy that you guys are sending. So if you guys have something, some problems, you guys could send me, send them away. But if I'm busy with my phone, if I'm busy with real life, I'll probably take some time. Would be happy if you guys have already tried it and you have insights and comments. Okay, so just don't send stuff that you guys don't really need. I'm hoping that I could be of help. No, not just send stuff because you want to send stuff. Okay? Yeah. Would take college physics, mathematics, chemistry, economics, and mechanics problem. Okay? So basically, these are I would say I'm confident topics of I'm confident with. So if you guys have questions about those topics, sure, why not? If you guys have questions about other stuff other than these topics, you guys could send them too, but not necessarily I would be able to help you guys, right? Okay, so I'm just gonna like blank out the name because he said I don't have any alias. Okay, I don't want to dox him, so I'm just gonna blur his name or blank out his name on the video. I hope you guys don't see it. Anyways, thank you so much, Mr. Banana. Okay. Topic subject of the problem. This is a differential equation problem. Okay. Let's hope we can solve this. Okay. Let's hope we can solve this. Okay, Mr. Banana, what did you send to us? Oh, let's print screen this. Okay, so basically, let's read the problem. Question 1, a curve passes through the point uh, uh, I'm gonna read this first. Let the 1 pi 6, let the slope of the curve at each point xy be y over x plus secant y over x. X is greater than 0, then the equation of the curve is, okay, so let's read it now slowly. We're talking about curve, right? And differential equation. Okay, then it passes through the point 1 of pi over 6, which is basically this is x equals 1, y is equal to pi over 6. Let the slope of the curve at each point xy, slope or m, is equal to y over x plus secant y over x, where x is greater than 0 or basically all positive. Then we're looking for the equation of the curve. Okay, first off, let's analyze this. What topic is this under differential equation? I have not made a video about this yet, but I think this is like right up the first topics. Okay, and I have taught this to the students, very fresh. Okay, to my students. I am a teacher, I am an instructor, and I have taught this to my students very fresh, probably last week, since this it says curve in the problem. Right, under differential equation, family of curves. Okay, family of curves. So I'm basically just analyzing the problem and trying to like simplify it to what I know. Right, so I think this is from family of curves, and it's talking about the slope of the curve at each point xy. Okay, I'm gonna pass on that. I'm gonna focus on the point 1 pi 6. I'm gonna put this as IVPs, or initial value problem. So basically the problem has a value, and we're gonna substitute it later on the general equation after integrating our differential equation, which I think this will be our differential equation, this one, and we're gonna get a particular solution. Okay, so if you guys watch my elimination of arbitrary constant and separable equation, I think I have explained their general solution and particular solution. But either way, I hope Banana knows what I'm talking about. And basically, this is for Banana, and I hope you guys know what I'm talking about. Whoever is watching this, right? My viewers. Okay. Anyways, I'm talking too fast and I'm talking too much. I hope you guys are understanding me. Okay, this is our equation, right? And I said before that because we're looking for a particular solution, the only makes sense here is the relationship between the slope and the curve. Okay, so slope is a very particular term used to describe basically the movement of the line, okay, or the straight line, and basically dy over dx. Okay, basically on a first order straight line or first order equation, first order derivative or a first degree equation, when you differentiate the straight line, it will always become slope. Okay, and the slope describes your line. Okay, and so far this is not the equation is not saying any second degree or third degree. I'm gonna assume that the curve being talked about here, the slope of the curve at each point is first degree. Okay, and first order. Okay, first order, first degree, dy over dx, and this will become our differential equation. Okay, so far I have not solved this, but I think I'm making sense. Let's see. I think there's a if you read this, there's like multiple choice here. Okay, so we're gonna see cosec. What's a cosec? Cosecant, CSC. Right? I haven't not seen cosec. Okay, I know CSC, cosec. Okay, anyways, I dy over dx equals to y over x plus secant yx. These are differential equation. I'm gonna distribute dx or multiply both sides of dx. dy is equal to y over x plus secant y over x dx. Okay? So by experience, this is what you call first order differential equation, ordinary differential equation, and I'm seeing a property of homogeneous equation. Homogeneous equation. Okay? Because homogeneous equation requires the equation to be of the same degree. Basically, this is 0 degree. Y over x, which is both first degree, and 1 minus 1 is 0 degree. Second, yx has like 0 degree because y over x inside second is basically 0 degree. Right? So basically, the degree of the variables here are homogeneous. Okay, or the same. Okay, and in order to solve for homogeneous equation, we use y is equal to vx, where v is a variable, where dy is equal to v dx plus x dv. Okay, I have not made a video about homogeneous yet, but I hope, Mr. Banana, so far so good. You are understanding that we're gonna use a homogeneous, or the process of solving for homogeneous equations in our problem. Okay, and substituting that, we're gonna have like dy on the left side will become v dx plus x dv. Okay, is equal to y on the numerator, all the y in the numerator will become vx over x plus secant vx over x, then dx. Okay, notice that x will be a common multiple or will be cancelable. Right? So our equations now will be x dv. Since dx is on the right side, I'm gonna put the v dx, this one, on the right side. Okay, since the dx or the derivative x is on the right side, right? So there will be like the equation will be like v secant v, okay, dx minus v dx. Okay, so there's like a common term here. We could cancel that. The equations will be x dv plus secant, or equal positive secant v dx. Okay, that will be our separable equation. After substituting y equals vx, we're gonna have like a separable equation. We're gonna divide both sides by 1 over x and secant v. Okay, dv over secant v is equal to dx over x. Okay, are we like leaving any positive or negative sign? No, so far so good. All our signs are negative or positive. All our signs are positive, so there won't be any negative sign, right? So second, on the, I'm just gonna convert secant into cosine, because 1 over secant v is equal to 1 over cosine v, and that's basically like cosine v, right? So that's cosine v dv is equal to dx over x. Integrating both sides, we're gonna have like sine v is equal to ln x plus c. Okay, ln x plus c. So far what we have is our general solution. Okay, so this is our general solution, and I just like look at our problem before. Okay, we need to use our point 0.1 pi 6, right, for our IBP to get our particular solution. So we call this general solution. To get our particular solution or equation of the curve, let's substitute x and y, right? Oh yeah, we still have v, right? So if y equals vx, then v is equal to y over x. Then our equation will become sine y over x is equal to ln x plus c. Right? Okay. So let's substitute x and y. Sine is pi over 6 over 1 is equal to ln 1. Okay, so this is a parenthesis, right? Plus c, right? And ln 1 is 0. Okay, and sine pi over 6, unit circle, remember unit circle, pi over 6, if pi is equal to 180, and pi over 6 is basically 30 degrees, right? Pi over 6, and I always remember that the short end is 1/2, and the middle end is like square root of 3 over 2, and the hypotenuse is 1, okay? Or 0.866 and 0.5. So basically, this is 1/2. Okay? C is equal now to, okay, our particular solution now is sine yx is equal to ln x plus, okay? This is now our particular solution with substituting C as 1/2. Okay, let's check the choices. Ooh, okay. The choices is logarithmic. Okay, but so far, I think I can explain this, right? Okay, so the real integration of ln x is, of 1x, if you derive, or sorry, integrate 1x, that's like ln x. Okay, that's the integral form. It's associated in Google. Everyone knows it. I mean, everyone who studies integral calculus knows it, right? So, just for reference, some books, okay, so far our equation looks like the letter A, okay, except the ln x one, right? But in some books, instead of using ln x, we use logarithmic e x, right? Okay, so the e on the lower part denotes the exponent, or the base of our exponent, which is e. Okay, usually logarithmic is base 10, but for natural logarithm, okay, for natural logarithm, ln x, oh, sorry, or 10, or what, e raised to x is equal to logarithmic e x. Okay, is equal to ln, or sorry, e raised to x is basically is equal to, or this logarithmic is equal to ln x. Okay, all right. I'm just saying that instead of using logarithmic x, we use ln x, right? Okay, so I think this is the final answer. Okay, I hope I helped you in your problem, Mr. Banana, and thank you so much for sending this. So yeah, guys, if you guys have any, and if you guys need help, if you guys want some clarification, or if you guys want another explanation, you guys could like send me your problem solving stuff, and I try to solve them and make a video about them, right? And I'm trying to explain it for you guys, right? So it will be better if you guys like put a comment or some insight on the Google form, right? So what's this? I think this is like his link. We're not gonna click that. We're not gonna click that, right? Anyways, thank you so much, guys. I hope you guys learned something, and if you guys have learned something, and if you guys have any thoughts, you guys could comment below. Okay, you guys could comment below and tell me what you guys think of the video. I think I should probably raise my voice. I should probably make my mic louder, but yeah, if you guys if this video helps, thank you so much, and like and subscribe, guys. I'm planning to do more. See you guys soon. Bye bye.